Hello everyone. We are here going to explain about the optical fiber coating in ceramic. So first of all, let me introduce my colleague. There is a Diva Calista Amalia, and there is Muhammad Pasha Arrighi, and there is me Radifan Abrar. So let's get to the topic. Okay, next slide please. So the introduction of the optical fiber coating. So let me explain about the ceramic first itself. Since prehistoric times, an engineered ceramic and glass material have had a significant role in most technologies. On this basic level, ceramic is a solid material comprising an inorganic compound of metal, non-metal, or metal with atoms that are primarily held in ionic and covalent bonding. Its crystallinity ranges from highly oriented to semi-crystalline, vitrified, and often completely amorphous, like example, a glass. A varying crystallinity and electron composition in the ionic and covalent bonds cause the most ceramic materials to be good at thermal and electrical insulator, extensively researched in ceramic engineering. Okay, next. So what I'm going to explain for the next topic is what makes this ceramic coating is special. So the specialty of embedding ceramic coating into a fiber optic is first its diverse parameter coverage. A composite structure embedding an optical fiber sensor have received a growing interest in recent years due to its ability in detecting a diverse parameter of usage. Hence, and then it forms a smart materials and structure. In general, there are three classes of coatings that are successful to be applied on optical glasses. That is why the ceramic embedding coating has a broad range of layer embedding materials. And then there is a various fabrication method. The variety of the technique in fabricating the embedding coating has made the ceramic as the most favorable material for coating. And then there is the final one is the cost efficiency, which makes a range of both physical and chemical properties is feasible while maintaining the cost as low as possible. Okay, next.
Okay, so next I'm going to talk about the ceramic component on the optical fiber coating. So the main component on the ceramic coating is using the alumina ceramics, which is made from a white granular material or a very fine silky dense powder refined from a bauxite. So this important source is, which is the alumina, is a result from the Bayern process. The purification of the result of the Bayern aluminate liquor to minimize organics, iron oxide, and silica, reduction of sodium oxide content, special condition of precipitation, and calcination and grinding of the calcinate material is a process to achieve the result of this alumina ceramic. And then the other process could be involving acidification of the aluminate liquor. It could be drying, also calcination or other treatments of the aluminum. So it could reach a certain percentage of alumina and other component to make a good alumina ceramic. And then the alumina itself is a major engineering material that has excellent mechanical and electrical properties, which makes it applicable for a wide range of uses. And here's are the typical properties of alumina ceramic. As you can see, it could be variated. For the alumina, it could be range about 90%. It could be other percentage as well, but here's are the example of the composition. There's also the physical properties. the alpha of the alumina oxide, the VT surface area, the ultimate crystal size, the specific gravity, and particle size. And then the main function of the alumina itself, being the most well-known and most commonly used fine ceramic material, it is physically and chemically stable. The thermal properties itself, it has high heat resistance and high thermal conductivity. It has a high strength and high hardness for the mechanical properties, and then it's also have high electrical insulation and high corrosion resistance and biocompatibility, which is why it could be used for the optical fiber coating. And then the alumina ceramic, being hard and having high young modulus, it could storage a large reservoir of elastic strain energy when under stress. It adds to why it is used for the optical fiber coating. Next.
The crystal structure. So aluminum oxide is a ceramic compound with a hexagonal crystal lattice. The oxygen anions divide a hexagonal closed pack or HGP structure, and the aluminum cations occupy 2 to 3 of the octahedral sites in the HCP lattice. Because of the high charge, the 3 plus, on the cations, the aluminum ions want to have the maximum spacing possible in its structure. Due to that, the empty aluminum sites in the basal planes of the cell will result into the structure repetition of itself into every 6th layer, giving the C value of 1.299 nanometers. Okay, next. An aluminum oxide is a polycrystalline ceramic material that is presented in different phases according to its alumina purity and both physical and mechanical properties. The crystal lattice exists in 3 types of phase. Those are the gamma phases, the theta phases, and the alpha phases. The gamma and the theta phases are an unstable form of aluminum phases and will be subjected to shifting into another phases at certain temperature. Sequentially, the gamma aluminum oxide phase will be the first to alter its crystal lattice at 700 to 800 degrees Celsius into the theta phases. Then the transformation continues by the theta phases under an ambient temperature at 1050 degrees Celsius into the final lattice of the alpha phases. The low surface energy and large specific area acquired from the gamma phases enables it to be used as a catalyst during a fabrication of alumina oxide. And then for the alpha phases, it is formed completely all well around 1000 degrees Celsius and are thermodynamically stable from of alumina, and it is utilized as a coating layer to hinder or even prevent any surface degradation. The enhancement is achieved through the embedment of the alpha phase alumina oxide into its surface of component, thus providing with a good mechanical properties, chemical inertness, and thermal stability, and other properties that are crucial. Okay, next.
Okay, for the next material is about fabrication techniques. There are several types of thermal spray coating processes. They differ in how thermal and kinetic energy is applied to the coarse material. So the form of the coarse material could be a wire or even a powder. The temperature of the flame and the relative velocities also vary the coating processes. And each method has advantages and their own disadvantages, and some are specifically suited for the certain coating. And for the first one, the first two that I'm going to explained are the combustion flame spraying and the plasma arc thermal spraying. The first one is a combustion flame spraying. So this method is a primary principle is to employ oxygen and fuel gas to generate a sufficient heat required to melt the wire, which serves as a feedstock materials. And the wire is usually contained in a spool or coil, which is held on a separate wire holder. And it also fed into a gun by the air pressurized electric powered drive mechanisms, where the oxygen and the fuel gas are mixed in a ignite and to generate a heating zone that is used to melt the wire, and the molten droplets are pushed onto the substrate using a limited stream of compressed air. The working temperature of the heating zone is around 4,000 and 16,000 until 408 degrees Celsius, a degree Fahrenheit, sorry, and the velocity of the particles is about 800 feet per second. And below, in the left one, is the combustion wire system uh, pictures. And the next one is the plasma arc thermal spraying. So the plasma spraying is the process of the spraying molten or heat softened material into a surface to create a coating. Further materials is injected into a high temperature plasma flame and rapidly heated and propelled to a high velocity. The heat substance collides with the substrate surface and cools quickly, forming a coating. This plasma spray technique is known as a cold process. Because the substrate temperature can be kept low during the processing to avoid damage, the metallurgical changes and deformation. Unlike the combustion methods, plasma spraying has the benefit of being able to spray materials with very high melting points, such as refractory metals like tungsten and ceramic like zirconia. And for the uh, picture on the right side is a schematic diagram of the plasma spray process. Oh, next. And these are the last two of the techniques. The first one is a high velocity oxygen fuel, or HVOF. HVOF is a thermal spray system that uses the combustion of gases like hydrogen or liquid fuels like kerosene to produce heat. Within the combustion area, fuel and oxygen combine and atomize under conditions that ensure the proper combustion mode and pressure are maintained. The method generates a high velocity that is employed to drive the particle at near supersonic speeds before impacting on the substrates. And the last but not least is the arc wire thermal spraying is the idea to produce an arc between two metallic wires that act consumable electrodes. Because of the potential difference between the electrodes, an electric arc is created, the wires melt, and the compressed air propels the molten droplets into the prepared workpiece. To make a pseudo alloy, two different wires might be utilized at the same time. Anti-corrosion zinc and aluminum coatings, as well as machine element work on a massive components, are two of the most common use for the arc spray techniques. The higher particle velocity making coating by arc spraying are better than in a flame spray coating. Next.
Okay, so next I'm going to talk about the resources of raw material in Indonesia. So the manufacture of alumina comes from various raw materials such as bauxite, corundum, clay, kaolin, anorthosite, and etc. So the main raw material is a bauxite. In Indonesia itself, the potential and a reserve of this bauxite deposit are quite abundant. So in 2016, Indonesia's total bauxite resource were about 900,000 million tons, and the reserve itself, it reached about 380,000 million tons, with the aluminum oxide levels ranging from 27 to 55%. And then in 2017 to 2018 to 2019, it always increased in the total production, which is in 2019 it reached about 11 million microton. And then until now, the bauxite mining processes on Bitan Island is the most largest mining of bauxite in Indonesia. And then the most of Indonesia known reserve of bauxite is located in North Sumatra, which is on the city of Pinang. It is also in Riau, which is on Bulan Island and Bitan Island, like I mentioned before. And then on the West Kalimantan area, it is in Sandai, Mabungkung, Balai Berkuah, Pantus, and etc. And also on Bangka Belitung, it can be found in the Sigembir area. And then based on the mining business permit in West Kalimantan, the potential of the production of the bauxite, it could reach up until to about 5 million MT, and then the reserve itself, it could reach about, the production, it could reach about 900 million tons, and the reserve itself, it could be about 500 million tons. So here are our resources. That's all from our groups. If you have any question, feel free to ask on the comment section. Thank you.